Okay, Calc, I'm gone today. This is section 3.2. We're going to get through all these notes here, and there's a lot of like graphical things and stuff, and it's going to look really confusing, but it's not too bad. 3.2 is finding limits, okay? I'm going to talk about what a limit is, okay? A limit is basically finding a y-coordinate. So you're like looking for y-coordinates is all you're doing, okay? Now, we're looking for y-coordinates, specifically where like funny business happens. So like where the x fails, I'm going to say, okay? And the x fails like places like where holes happen, or like vertical asymptotes happen, okay? So what we're saying is like, okay, we know that there's a hole at this point, but if there wasn't, what would the y-coordinate have been, okay? Or we know there's a vertical asymptote here, but if there wasn't, what would it have been, okay? And sometimes the answer is that the limit does not exist, okay? And we'll see a video of that, like the Mean Girls thing. They had the limit does not exist, okay? That's a thing. But, that happens every once in a while. But when we talk about like finding a limit, we're finding the y-coordinate. We're looking for like the y value for places where the x-coordinate fails. Now, keep in mind that sometimes they will try to trick you and they'll have you find, I'm going to scroll to the very back. Okay, go to the back of your notes here, and let's talk through 5 and 6 real fast. Okay, we're going to do those two. We're going to like work backwards, right? So number 5 is saying we want to find the limit as x goes to -1 of 4x plus 7. Okay, so that's the wording that they'll use. The limit as x goes to -1 of this thing. Okay, so I think about what this thing looks like, right? 4x plus 7 is like y equals 4x plus 7, right? Okay, and that is going to be a linear function starting at 7. Okay, and then you go up 4 over 1 or down 4 to the left 1, right? And he's going to be a line that looks like this, right? Okay, now this is a linear function. He has no funny business, okay? So they're putting this in here to try to trick you because he has no vertical asymptotes. He has no holes. He has no jumps, no skips, no like pointy places, no nothing. He's a straight line. So all we're doing is trying to find the limit. And again, the limit is the y-coordinate, okay? So we're trying to find the y-coordinate when the x-coordinate is -1. So I'm going over here on the x-coordinate, -1. Oop, that has a y-coordinate of, I think, 3. It should be 3. I didn't go over very far. Okay, so if we're up at 7 and we go down 4 over 1, that should be right here at 3, right? Okay, so -1 has a y-coordinate of 3, so the limit is 3. Now, I also can do that by just plugging -1 in for x, right? 4 times -1 plus 7 is 3, okay? So what you're always going to want to try to do first is when you have a function and you're trying to find the limit, try to plug that number in for x into the function first, okay? And if it works, then there was no holes or no vertical asymptotes or anything like that. But if it doesn't, then there's probably like some funny business going on, like a hole or something, right? Like a vertical asymptote would be like something like 1 over, let's say, x minus 3, right? If I'm trying to find the limit as x goes to 3, I obviously can't plug 3 in here because then I'll end up with 1 over 0, and that won't work, right? There's a vertical asymptote at 3. So that we would have to look at a little bit closer. But here, when we had a linear function, there's no problem. We don't have to, work around anything. We can just plug that number in, right? Okay, so here, this is the square root of 2x is what he is. And if we look at that, the square root of 2x is just a square root function, which does start here and it goes this way, but he's going to be a little bit higher because he is a horizontal compression or kind of like a vertical stretch a little bit. Okay, and if they would ask us for stuff like over here, like the limit as x goes to like -8, okay, that limit's not going to exist over here because the graph stops right here. Like he's not going to go to the left forever, right? But if we're looking at +8, we just go over 1, 2, 3, 4, 5, 6, 7, 8 and find the y-coordinate. It's going to be like some point right there. There's no funny business happening at that point. So all I can do is plug 8 in, and I have the square root of 2 times 8, which is the square root of 16, which is 4. and that's what the limit will be. So this y coordinate right here would be 4, okay? There's no funny business happening at that point. They're throwing these in there to try to trick you because they're just saying, what is the limit? Well, find the y coordinate, okay? The y coordinate doesn't have a hole or a vertical asymptote, so we just plug it in and we solve for the y coordinate and that's it, okay? So that is like the first thing that you're going to want to do. First, try to plug the limit in. Try to plug that number in for x and get a y coordinate, okay? If that doesn't work, then we have to look at it a little bit further, okay? So we're going to be looking at graphs in particular today. I'm going to go back up to the top. And if I go through any of this too fast, please pause, you know, and do that. Okay, there's a couple problems that you're going to have to do where you're looking at points in particular. So this happens to have a hole, right? Like they have, this is what the graph looks like, and we have a hole right here, okay? So we're again saying, what is the limit? What would the y coordinate have been if there wasn't a hole there, right? Like I can't plug 1 in here because I'll end up getting like 0 as my denominator and I can't divide by 0. So I can't just plug that number in. So what I do is I either look at the table or I look at the graph, okay? The graph here says, like I'm looking at this dot right here, if there wasn't a hole here, what would the y coordinate be? I'm guessing the limit's going to be 3, okay? But let's look at the table now, okay? So what we do is 1 is the value that we're looking at, right? And we know that we cannot plug 1 in for x because we end up with division by 0. We can't do it, right? So that's why they put a question mark here. So what they've done is they've taken this table, and you're going to fill a couple of these tables in on your homework assignment, and they go like numbers that are really, really, really close to 1. Like they start at 1.25 and then they inch their way in. Okay, 1.25, let's go 1.1 instead, or 1.01 or 1.001. And they say like, it starts at 3.8 and then it goes down to 3.3 and then 3.0 and then 3.00, okay? And we inch our way in on either side to numbers that are really close to 1 because I can plug in numbers that are really close to 1. I just can't plug in 1 itself, right? And so what I do is I compare these numbers and say, what value must fit in between there for a y coordinate? I'm going to guess that it's probably 3 exactly, right? Okay, so that's another way of finding a limit is just plug in numbers that are really, really, really close to that value on either side and then just kind of determine from there where that number fits. Okay, we kind of talked about that when we did section 3.1. We talked about like inching a little bit closer. Like, you know, I could have done 1.00001, right? If I wanted to plug that in, and I would have gotten a number really, really, really close to 3, okay? So it's okay, Emma, you're listening to yourself. So anyway, you just dropped a bottle. So there's that. So looking at a table, looking at a graph, you're just trying to find the y coordinate where the fun and business is happening, okay? This is the notation that they'll use right here, okay? They'll say the limit as x approaches, and this will be some number, they call it c, of some function. We just saw that a bit ago where it had like 4x plus 7 or whatever, and they'll say that's what the function is. And they'll say equals the limit. So our limit here in this case was 3, or the limit before I think was also 3. So that's the notation that they'll use. They say the limit as x goes to a number of this function equals this number, right? So that's kind of how that works, okay? All right, here we go. Let's look at another thing, all right? Evaluating limits, I'll look at the graph, and then we'll also look at the table here. Okay, so I have this function going on, and I'm going to first do what I told you to do, and let's try to plug 0 in. So I'm looking specifically at an x coordinate of 0. What's the y coordinate? So if I plug 0 in, okay, 0, 0, I end up with the square root of 0 plus 1 is 1, and the square root of 1 will be 1 minus 1, which is 0, and I can't have 0 on the bottom. Like, that's not going to work. So I cannot just get away with plugging 0 into that function. I have to either look at the table or look at the graph, okay? So looking at the graph, we see that what happens is this is a square root function. He does one of these things, and you can kind of hardly see this very well. Here's the y-axis, and I don't know where my x-axis is, right here maybe, something like that. There's my x-axis, okay? Let me see. I can't really see what this y-coordinate is. I think this is at 1, so I'm going to guess that maybe this is at 2. We're looking at this spot in particular, so this has an x-coordinate of 0, and this is 0, comma, what? Like, what is the y-coordinate at that place where it, like, poops out, where the hole is, right? Like, where is that y-coordinate located? So what I do is I look at the table, and here's where 0 is, and we started at, like, like 0.01, and then we went 0.001, and then we went 0.00001 or whatever, right? Then we did the negative ones as well, and we're inching closer and closer and closer to 0 to figure out what this value is, all right? This one ends up being 1.99995. This is 2.000005, whatever. So I'm going to guess that this middle guy right here is a y-coordinate of 2, kind of like we guessed over here. I couldn't really see it very well, but I'm guessing that that y-coordinate is 2. So the limit equals 2, because if there wasn't a hole there, if there was no hole there, the y-coordinate would be 2, right? That's kind of how this works, all right? We're trying to figure out what the value would be if there wasn't funny business happening at that point, okay? All right, here we go. Now we're going to talk about a piecewise function, so where we have two things going on at the same time, right? A piecewise function. Okay, so what this is saying, let's read the top of this. This is saying that y equals 1 when x is not 2. Okay, so for all other values besides 2, we're going off of the graph y equals 1. Okay, y equals 1 is here at 1. I don't know if you can see this y-axis right here. Okay, here is 1, and I'm going a straight line all the way across, except at 2, right? At 2, there's a hole right here, and it bumps down to y equals 0. So at 2 exactly, y equals 0. So this is kind of like the, on your birthday, you pay 0 amount of money at an amusement park. At, like, when it's not your birthday, then you pay like $1 or whatever, you know, like that's kind of how this whole works, right? So what we have going on here is we have a dot down here at 0, okay? This is the coordinate point of 2, 0, right? So when we're asking for the limit, I'm going to say the limit as x approaches 2 of this function. I'm going to just call it f of x rather than rewriting this stuff down here. I'm going to try to figure out what that limit is. Now, here's the tricky part. I know that 2 actually has a value of 0, right? But if that was not there, looking at all of the rest of the behavior on either side of that point, everything else in this graph is leading me to believe that that y-coordinate should be 1, right? Even though I know it's 0, the limit is actually going to be 1 because everything else, this side right here tells me, oh, it's going to a coordinate of 1. Oh, this side is telling me this side is going to a y-coordinate of 1. So the limit is actually going to be 1. Even though his actual value is down here at 0, everything around it leads me to believe that that y-coordinate should be 1. It should not be 0. It should be 1, right? Even though the piecewise function tells me it's actually a value of 0. It shouldn't be 0, it should be 1, and that's what the limit is the limit is 1. Okay, I hope that makes sense, all right? You look at the behavior on either side, okay, on either side of that value and figure out what it's approaching from the left and from the right, okay? All right, let's go to the back side. Limits that fail to exist. Here we go. Okay, this is something. All right, right here. Okay, so we have this going on, the limit of this function, and they've gone ahead and graphed this function for us. The absolute value of x over x looks something like this. Okay, it is a kind of like a piecewise function. That's what this, they've separated it out into 2 pieces for us here. If this confuses you, don't worry about it, but graphing the absolute value of x over x ends up looking like this. We have like one little chunk right here, and we have an open circle there, and we have one little chunk right here, and we have an open circle here. All right, so I'm going to introduce something else to you that talks about left hand and right hand behavior, okay? So what I'm going to do is I'm going to say, let's find the limit as x goes to 0 plus, okay? And I'll tell you what the 0 plus means here in a second, but there's that, okay? I just did my function, so I'm going to find that limit, and then I'm going to do the limit as x goes to 0 minus of that function. Right? And we're going to do both of those, and then we're going to look at, in general, overall, what is the limit as x goes to 0, okay? And this is where the Mean Girls thing comes into play, where the limit does not exist thing, right? So show that the limit does not exist. Here's what we're going to do, okay? This little guy right here, this plus sign means from the right side. Plus just means from the right. Here, this means from the left side, okay? All right, so we're going to look at each one of these, and I'm saying as my function comes in to 0, 0 on the y-axis is right here. This is where the 0 is. Oops, excuse me, 0 on the x-axis. This is where 0 is on the x-axis. This is an x-coordinate of 0, right? Left and right, this is where x-coordinate of 0 is. So coming in on the right side would be following along this little loop because that's where my function is. Coming in on the right side, it's telling me that the y-coordinate should be 1, right? Okay, if I'm coming into 0, which is here, this is 0 on the x-axis, coming in from the left side, it's telling me that that y-coordinate should be -1, okay? Coming in on the right, it's telling me everything on the right side should lead to a +1 y-coordinate. Everything on the left side is telling me it should lead to a -1 y-coordinate, okay? Now, when I try to combine these two and say, okay, then what's the behavior in general as we're just going to 0 from both sides together? Because these two are conflicting and they are not approaching the same value, then the limit does not exist, okay? Because they are conflicting. If this was coming in here and this was coming in here, then it would be a y-coordinate of 1, okay? If it was coming in here and coming in here, then it would be a y-coordinate of -1. But the fact is that they're coming in and this one's approaching 1 on this side and this one's approaching -1 on this side, so the limit is not going to exist because they are conflicting values on the left and the right, okay? All right, so I hope that made sense, all right? Let's talk about this one. Okay, discuss the existence of the limit. All right, here we go. I'm going to do this one left, right, and both sides together also. So I'm going to say the limit as x goes to 0 plus of 1 over x squared. Okay, this is that volcano thing, right? You guys called it, I don't know, a tree trunk or something instead. Whatever. Then we're going to look at the limit as x goes to 0 minus of 1 over x squared. And then we're going to do, in general, what's the overall limit as x goes to 0, okay, of 1 over x squared, right? So we're going to do these two first, combine them together, and see what we get for an answer here, all right? So let's look at 0. 0 on the x-axis is right here, okay? This is an x-coordinate of 0. All of these have x-coordinates of 0, so I'm like coming in on the left, or coming in on the right, coming in on the left, okay? So my graph, as I come in on the right side, he's going like this. On the right side, as I get closer and closer to this line, which is 0, it's going to approach infinity, right? Like the limit as it comes in on the right side is approaching infinity. On the left side, it's also going to be approaching infinity. So the limit, since these two are both the same kind of number, basically, this limit should also be infinity. So the limit as x goes to 0 should be infinite on both sides, right? So, like, that's how that works. It's approaching an infinite value as it gets closer and closer to that x-coordinate of 0. Now, here's the deal. If you say infinity, I will say, okay, that's correct, technically. But since infinity is not an actual value, they say that the limit does not exist because it does not have an actual y-coordinate value at that point, okay? So technically the limit does not exist, and the reason why is because it is approaching an infinite value, okay? So when they says discuss the existence of the limit, technically it approaches infinity on both sides, so it's consistent, right? We do have, like, these two are agreeing with one another, but that shows that there is no limit because the infinity is not an actual value, okay? So hopefully that makes sense. Let's go down here and let's talk about some of these, right? So in your first and second problem, what you're doing is we don't know what the limit is as we're going to 2. I cannot plug 2 in here because I'll end up with 0 in the bottom, okay? That's going to be bad. I can't do that. So what we're going to do is we're going to plug in these values, and we're going to see on the right side and on the left side what number is this number right here that it's approaching on either side. Okay, same thing with number 2. Find these numbers, find what they are approaching as it gets closer to a value of 5, which is here in the middle, okay? All right, these ones here, 3, 4, 5, 6, 7, 8, look at, like, what's happening on either side. So I kind of do the coming in on the left, coming in on the right, what is happening. So like number 3, we have this function, which is a linear function, which means there's no holes or vertical asymptotes or anything. So as I'm coming in, here's my x-coordinate of 3, and coming in on the right side, this is telling me that this y-coordinate should be 1. Coming in on the left side, this is telling me this y-coordinate should also be 1, right? So I'm going to guess that the limit is going to be 1. And in fact, if I plug 3 in there, into that function, 4 minus 3, the limit is 1. I could have just plugged it in to begin with, right? Okay, it's when you have stuff like Number 7, coming in on the right side, this is saying that the y-coordinate should be 1. Coming in on the left side, this is saying the y-coordinate should be -1. So since those are conflicting at that point, you figure out what to do from there, okay? All right, on the back side, let's talk about part D, because this always stumps people, okay? They want us to do 2 things, D and H. Let's figure out what f of 4 is, which means what is the y-coordinate actually at 4? Okay, so if the x-coordinate is 4, the y value is actually at 2, right? Like it actually has a physical dot at 2 for a coordinate. So f of 4 is actually 2 itself, right? But now they want us to find the limit at 4, okay? So at 4, here's where 4 lives, right? On the right side, it's approaching infinity. On the left side, it's approaching infinity. So had this dot not been here, I would assume that the y-coordinate for 4 should be some infinite value, right? Like that's what it's leading to believe on either side. It's not it's actually at 2, but the behavior on either side is telling me that it should be infinity, right? So we say that the limit is actually infinity or does not exist, because remember, if the limit's infinity, the limit does not exist, okay? And then these ones, just kind of think about what they look like, okay, and try to find those limits. So again, a limit is what the y-coordinate is if there is like a hole or a vertical asymptote or anything that does not allow us to actually plug the numbers in. Now, some of these you can plug in, right? So always try to plug it in first to find the y-coordinate. But if not, try to look at the graph or, do something like that to figure out what the limit is or what the y-coordinate is, okay? That is all that I have.